Hello, everybody. My job today is to help you figure out what's going on, sort of by reteaching some of the things in the notes packets. So, what I want you to do is to be able to follow along from home. In your Google Classroom, right, you can find your classwork tab. What I'd like you to be aware of is the resource library. The resource library has lots of things that will help you. One of those things is how to manage your Google Classroom. One of those things is how to write formulas in Google Docs. But lastly, you have a periodic table there. This is the same periodic table that we use in class. So I'm going to reference the periodic table that you can see here. Okie dokie, the periodic table that's there. I'm going to open this up in another tab so that I can get to that periodic table anytime I want. The other thing you should be aware of is that in our classwork tab, you have the entire notes packet to follow along. So here's our Unit 5 ionic bonding and the materials. I have answer keys to some of the pages. But there's also the notes and homework packet from pages 1 through 13. So this is the entire notes and homework packet. I'm going to open this up in a new tab so that I can reference that with you as well. What I'm going to be doing is using Google uh, Docs to show you what you would do if you were drawing on this at home. I realize that you can't do dot structures as well. So those, if I show them on the test, it's going to be just picking from some pictures. So I want you to be able to identify the pictures. So how do we know how many dots each atom should have? First off, we want to look at what element it is. So for the first example, B, I'm going to go to my periodic table and find B. Here's boron right here. So that means um, uh, boron is in the 3A column. So it has 3 valence electrons. So I'm going to draw 1, 2, 3 valence electrons for boron. I give 1 to each side before I start doubling up electrons. Let's look at Li. For Li is in the 1A column. So that means it's going to have just 1 dot. 1A means 1 valence electron. Let's go back. So now we have Li that has just 1 dot. Yay. Let's go on to Ne. Ne is in the 8A column, so it has 8 valence electrons. Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Very nice. That's the maximum it can have. Se is next. Se is in the 6A column. So that means Se is going to have 6 valence electrons. We're going to give it 1, 2, 3, 4, 5, 6 valence electrons for Se. Very nice. Let's do Ca. Ca is in the 2A column. That means it has 2 valence electrons. We're going to give it 1, 2. Sometimes people give, when they just have 2 valence electrons, they might give them to opposite sides. So another way to draw this would be 1, 2 valence electrons. Both of those are acceptable for Ca. Now let's check out N, nitrogen. Nitrogen is here in the 5A column. Even though it has 7 electrons total, it just has 5 valence electrons. So N has 1, 2, 3, 4, 5 valence electrons. Next up, we have He. He is in the 8A column, but look, He only has 2 electrons. Because of that, we're going to show those 2 electrons a little bit differently. This whole column here are the noble gases. All of them have 8 valence electrons because they are full. They have a complete octet. They do not want to bond. But He is the smallest and cutest noble gas because it only has 2 valence electrons total. We don't draw it with 8, we just draw it with 2. But to show that it is a noble gas, see, Ne was our other noble gas. Everything was full, everything was doubled up. Ca just had 2 electrons, but it is not full with 2. So to show that He is full with just 2, we give it 1, 2, both on the top for He. This is different. It's an exception. Be careful. Be careful. Finally, we have F, fluorine. Fluorine is in group 7. So we do 1, 2, 3, 4, 5, 6, 7. 7 for fluorine. I hope this helps with your ionic bonding first page using dot structures. Good luck.